أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. There are several channel models used in wireless communication systems. Each of these models is designed to capture very specific characteristic of transmission medium. Here are some commonly used type of channel model are discussed in this unit. In this unit, we'll mostly discuss about the general type of channel model. Firstly, we define, and then we discuss about some most commonly reported channel model for wireless communication system used in the textbook and are very effectively used for different specific purpose and in order to model the wireless communication channel under the different environments. There are several types of channel model used in wireless communication system, each designed to capture a specific characteristic of transmission medium. Here we discuss about the most commonly reported and very general in nature type of channel model. One of the most important type of model is deterministic channel model. Deterministic channel model describes the channel behavior using a deterministic mathematical equation, which is opposite to the random process. These models are based on physical principles and provide a deterministic mapping between input and output signal received, transmitted, and receiver signal. Deterministic models are often used in scenarios where the channel characteristics are well defined and they can be accurately modeled, such as line of sight wireless links. Another important general purpose model is the statistical channel model. The statistical channel model are based on statistical analysis of real channel measurement. And these models capture the statistical properties of the channel, such as fading, shadowing, and multipath effects. Uh, Statistical models are more suitable for scenarios where the channel characteristics vary over time and are not easily predictable. Example of statistical models include Rayleigh fading, Gaussian fading, and long normal shadowing models. Multipath channel model are specified specifically designed to capture the effect of multipath propagation, where multiple copies of the transmitted signal or message arrived at the receiver with different delays and amplitude due to reflection, diffraction, and scattering. This model describes the channel as a combination of the direct path and multipath delay and attenuated path. Example of multipath channel models including the Sole Venezuela model, the Jakes model, and the COP207 models. And similarly, physical channel models aim to accurately represent the physics of the transmission channel or medium. They take into account factors such as antenna characteristic, propagation environment, and electromagnetic properties of the medium in terms of EMI and other type of noises. Physical channel models are commonly used in wireless communication system to simulate realistic wireless channel. Example include the 3GPP spatial correlation, a spatial channel model, and the winner channel model. Some use simulated channel model. Simulated channel model are created through the computer simulation based on mathematical model and some very strong assumptions. These models are useful when the real world measurements are not available or when it is impractical to perform extensive measurement. And simulated channel model can incorporate various channel effects such as padding, interference, and noise, and can be tailored to the specific communication scenario. Generally, the war zone communication transfer model are used by the simulation models. It is important to note that the choice of the channel model depends on the specific requirement of the communication system and the level of accuracy need to capture the channel characteristics. In practice, a combination of different models may be used to account for various aspects of channel behavior. There are several mathematical models used to represent or analyze communication. Here we have discussed commonly used mathematical models which are reported in literature or as well as in textbooks. The most important is additive white Gaussian noise model, which is called AWGN model. AWGN model is a very simple but widely used model for analyzing the effect of noise in communication channel. It assumes that the receiver received signal is corrupted by some additive white Gaussian noise, where the noise samples are independent and identically distributed with a Gaussian distribution. This model is particularly useful for analyzing digital communication system and is often employed in the analysis of error probabilities and capacity calculation. Another one is Rayleigh-Fading model. The Rayleigh-Fading model is a statistical model used to describe the effects of multipath propagation in wireless communication channels. It assumes that the magnitude of the received signal follows a Rayleigh distribution, while the phase is uniformly distributed. It's a very reasonable assumption for most of the wireless communication systems. This model is commonly used when there is no dominant line of sight component in the channel and is highly suitable for analyzing the performance of wireless communication system in fading environment. Ricin fading model. The Ricin fading model is another statistical model used to describe wireless communication channels. It incorporates a dominant line of sight component in addition to the multipath component. In other words, we can say that the Ricin model assumes that the magnitude of the received signal follow a Ricin distribution, which is a combination of the deterministic component and a really distributed component. This model is often used in scenarios where there is a strong line of sight component, such as in urban or indoor environment. And similarly, long normal shadowing model, the long normal shadowing model is used to capture the effect of large scale variation in signal strength due to obstacles and environmental conditions. It assumes that the received signal power follows a long normal distribution with the variation caused by factors such as building, terrain, or vegetation. This model is commonly used in wireless communication systems to account for long-term signal variation and is often combined with other fading models. Similarly, channel impulse response model, which is also called CIR model in the textbook literature and literature. The channel impulse response model characterizes channel properties as a time-varying filters. And it represents that the channel is a sequence of impulse response, which describes the amplitude and delay of the multipath component. The CIR model is comprehensively used to analyze the time-based dispersion effect of the channel, such as intersymbol interferences in digital communication systems. It is often derived from measurement or can be simulated using mathematical models such as Saleh-Venezuela model or the JUX model. These are a few examples of mathematical model used for channel characteristic in communication systems. The choice of a model depends on the specific characteristic of the channel and the level of accuracy required for the analysis or simulation. In practice, more and more complex models and combination of the model are used to capture the various aspects of channel behavior.